Linears, quadratics, and cubics, oh my! Today we're looking at graphical solutions to different types of equations, and this lesson is going to take a lot of previous knowledge in order to access it. But don't worry, I'm linking some lessons down below in case you need to get caught up. My name is Miss Danielson, and let's take a look at what you need to know before we get started. Graphical solutions are the use of graphs and the xy coordinate points on a graph to solve for unknown variables in algebraic equations. So the required previous knowledge that you must have before we get started is you must be able to rearrange algebraic equations. You should be able to graph lines with confidence. You should be able to substitute into equations and complete tables of values. That's these things here, where you know different values for x and you're trying to find their corresponding values for y. And you should be familiar with graphing simultaneous equations. Now, we're not going to focus on these 4 bullet points today, so if you're still struggling with those skills, check out the description box down below. If you're ready to get started, let's do that. So the whole idea of this lesson is that you're going to be given a curve, or you will graph your own curve, and then you're going to use that curve to solve some given equation. If you're asked to find the roots of a quadratic, the equation you're asked to solve is where is that quadratic equal to 0. So for example, if we're asked to solve to find the roots of this quadratic, you may be familiar with factorizing quadratics. If you know how to factorize this, you should know that the roots are at -3 and 2. But as we're graphing today, you don't actually need to know how to factorize these quadratics. And as you may have seen before, some quadratics can't be factorized. So we're going to try graphing this quadratic for values of x between -4 and +3. So I'll set up my table of values with x values from -4 up to +3. And I've already filled this in by substituting these x values into the equation. So -4 squared plus -4 minus 6, that gave me my y coordinate. My y coordinate will be 6 while my x coordinate is -4. X was equal to -3. I did the same. I substituted it into the equation. So -3, don't forget to use brackets, -3 in brackets, squared outside, plus -3 minus 6, that gives me 0. So I've got some coordinates that I'm going to plot on my graph, and I know that my x-axis needs to go from -4 up to +3, and I can see by the y coordinates I have in my table of values that my lowest y value is -6 and my highest y value is +6. So I'll set up my axes appropriately. I've plotted a nice smooth symmetrical parabola, and it's a positive parabola because the x squared term was positive. And I can find the roots just directly from this graph by remembering that the roots are where the quadratic is equal to 0. So that's where y is going to be equal to 0, because if you look at the graph, I graphed the curve y equals x squared plus x minus 6. Well, I want to solve the equation 0 equals x squared plus x minus 6. So I'm replacing that y with a 0. I'm assuming that y is equal to 0 at the solutions, so I can find that on my graph. Y equals 0 on my graph is actually the x-axis. It's a horizontal line that crosses the y-axis at 0. So I'll graph that on there, and I can see there are 2 solutions to this simultaneous equation. My curve crosses my line in 2 places, once at -3 and once at +2. So that's my solution. X is equal to -3 and x is equal to 2. Those are my roots. Sometimes we're going to need to do a bit of additional graphing. We're not always looking for the roots, so we're not always looking for just where the curve crosses the x-axis. In this case, for example, I've got the curve y equals x squared plus x minus 6, but I want to solve the equation x squared plus x minus 6 equals 7, not 0. So this time, our solution will be found where y is equal to 7, because as you see, although I've graphed the curve y equals x squared plus x minus 6, I actually want to solve where I'm replacing the y with a 7. So let's graph the line y equals 7. Hopefully you recognize that that is just going to be a horizontal line which crosses the y-axis at 7. And we can see that once again we have two solutions. We know that our solutions can be found where the curve is crossing the line, because we're solving the equation where the equation for the curve is equal to the equation for the line. So my solutions are where x is equal to negative 4.1 and where x is equal to 3.1. Always make sure you make your answer clear with a nice clear answer statement. Now this time my answers are not exact. I couldn't see exactly what x values I'd found. However, I can see that one of those answers is just below negative 4, so negative 4.1, and the other answer is just above 3, so 3.1. It doesn't need to be perfect. However, your answer must match your graph, and your graph must be accurate enough to be reasonable. So make sure that your curve is nice and smooth, symmetrical, and neat. Taking this one step further, sometimes we need to do some algebraic working before we know how to use the graph or what additional equations we might need to graph. So for example, 3. Again, we've already got the graph of the curve y equals x squared plus x minus 6, but we're trying to find the roots of y equals x squared plus 2x minus 2. Always look carefully at the question. Notice that that is not the same equation. So what we're going to need to do is, if we're going to use the graph y equals x squared plus x minus 6, we somehow need to rearrange the equation that we want to solve into the format where we have the equation of the graph equal to something. So we want to solve to find the roots of x squared plus 2x minus 2. So we want to solve the equation x squared plus 2x minus 2 equals 0. I don't want to have to graph another parabola here. That's going to be more difficult than necessary. So I'm going to rearrange this equation so that I have x squared plus x minus 6 equals something. So I want to match the terms here. I've already got the x squared terms the same. To match my x terms, I need to take one x away from this. And to keep my equation balanced, I'll take one x away from both sides of that equation. So I've got the x squared term as I like it. If I do 2x minus the x, I'll have my x terms matching as I like it. But I still need to match my number terms. I want x squared plus x minus 6. I have x squared plus x minus 2. So I'm going to need to subtract another 4 from there. So subtracting 4 from both sides of the equation, I'm going to end up with x squared plus x minus 6 on one side of my equation and minus x minus 4 on the other side of the equation. So this time, I want to see where that curve is equal to this line, y equals negative x minus 4. So let's graph the line y equals negative x minus 4. And as we can see from that line, it crosses the curve in two places. I've got two solutions again, and I'm going to have to estimate them. One of my solutions is nearly at negative 3. The other solution is almost at 1. My solutions are negative 2.7 and 0.7. Before we get into the practice exercise, make sure you know what different equations will look like when graphed. Because if you fill in a table of values and you start plotting your points and it doesn't look the way you expect it to, make sure you can find your mistakes. So for example, horizontal lines always have equations of the form y equals some number. Vertical lines always have the equation of the form x equals some number. Positively sloping lines, so it's lines that start down low on the left-hand side and end up high on the right-hand side, will have a positive gradient. That's a positive coefficient for the x term. Negative sloping lines, which start high up on the left-hand side and slope downwards as we move to the right-hand side, will have a negative coefficient for the x term. Positive quadratics have equations which always have an x squared term. That's the definition of a quadratic. And for it to be positive, the coefficient of the x squared term, so the number in front of the x squared, must be positive. The signs of the other two terms doesn't matter. For a negative quadratic, again, there must be an x squared term, and the coefficient of that term must be negative. The definition of a cubic curve is that it has an equation with an x square in it. And the coefficient of that x squared term must be a positive number if your cubic is going to start down low on the left-hand side, have a couple of turns in it, and then end high up on the right-hand side. A negative cubic is just the opposite. It must have an x cubed term, but the coefficient of that x cubed term must be negative. And the curve will start up high on the left-hand side. It'll have a couple of bends in it, and it'll end low on the right-hand side. So if you know what those curves look like, you should be able to graph them. So let's go into some practice now. For question 1, I want you to graph this curve. Can you recognize what kind of curve that's going to be? Is it a line, a parabola, or a cubic? And is it positive or is it negative? You're going to graph this curve for x values between -4 and +2. So set up your table of values like this. Find your y coordinates that go along with these x coordinates and set up your axes. Your x-axis needs to go from -4 up to +2. Figure out how low your y values need to reach and how high they need to reach so that you can graph it. Then you're going to use that graph to solve the following. So you may need to draw some more lines and you may need to do some algebraic rearranging before you do that. For question 2, we've got another curve that you need to draw here. This curve you're going to draw for x values between -2 and +2. So set up a table of values like this. Find your y coordinates that go along with these x coordinates by substituting them into the equation. And set up your axes so that your x values reach -2 up to +2. But what positive and negative y values do you need on your axes? Then use that curve that you've graphed to solve these two equations. And once again, you may need to graph some other lines, and you may need to do some algebraic rearranging before you know which lines to graph. Go ahead and hit pause now and set that up as neatly as you can in pencil. Remember that your answers may be estimates, but your curves must be as smooth, symmetrical, and accurate as possible. Go ahead and do that now, and hit play when you're ready to take up your answers. I hope you've had a chance to hit pause, because here come your answers. For question 1, you should have set up your table of values like this, which would have helped you graph this curve. And for part I, you're trying to show where x squared plus 2x is equal to 3. So you need to draw the line y equals 3. If you needed a table of values for that, you'll see in that table of values that y is always equal to 3. So we've graphed our line and we see our 2 points of intersection. You should have exact answers for these. X is equal to -3 and x is equal to +1. For question II, we're showing where the curve x squared plus 2x is equal to the line x plus 1. So no algebraic rearranging was necessary, but you needed to graph the line y equals x plus 1. A table of values might have been helpful for that. And you can plot your points and draw that line and see that it crosses the curve in 2 places. So we've got 2 solutions here, although you would have had to estimate them. So if your answers are not exactly -1.6 and 0.6, make sure that they're at least close to these values. For part III, we're going to need to rearrange the equation before we can see how the curve could even be used to help. So rearranging this equation, we'll see that the curve will cross the line -x plus 4 for our solution. So let's graph the line y equals -x plus 4, filling in our table of values, plotting points and drawing our line. You can see that that line crosses your curve in 2 places again. Our answers should be exact again this time. X is equal to -4 and +1. For question 2, I hope you recognize that this is a cubic curve. It's a positive cubic. So when you're plotting your points, you should have noticed that they start low on the left-hand side. They may have a bend in it, but then they end up high to the right-hand side. So start by setting up your table of values. We can see that our y coordinates reach as low as -4 and as high as 12, so make sure you had space to do that. Then we need to see where x cubed plus x squared is equal to x. So we'll need to draw the line y equals x for that. We can fill in a table of values, but it should be fairly straightforward. Your y values are equal to your x values. So plotting those points and drawing that line, we can see that that line crosses our cubic in 3 places. And that's characteristic of a cubic. You may have 3 solutions, 2 solutions, or 1 solution in the case of a cubic. Although -1.6 and 0.6 are approximate solutions, one of your solutions must be exactly x equals 0. For part II, we've got a cubic expression, which is equal to some linear expression. However, we are going to need to do some algebraic rearranging to see how our curve is going to help us to answer this question. So rearranging that to get x cubed plus x squared equals something, we'll just subtract the 2 across. So x cubed plus x squared is equal to x plus 1. We're going to need to graph the line y equals x plus 1. So setting up a table of values and plotting those points to graph that line, we see that we now have only 2 solutions. There are only 2 points where our curve crosses our line. And those 2 solutions are exact. They're where x is equal to -1 and x is equal to +1. So how did you do? Hopefully your curves and lines are looking pretty good and you're finding fairly accurate estimates for your answers. If you had any difficulties or doubts, please be sure to let me know, and feel free to show me some of your curves if you're not sure if they're accurate enough. Until next time, keep practicing. Graphing takes a lot of work, so stick with it. Keep up the good work, and I'll see you soon.